Morning. We do have a long testing day as well as tomorrow, so we want to make sure we get as many of those kids in as possible. So if they happen to come in by 9 o'clock, please send them down to the gym. This is the ACT school day only for seniors who have not passed the FSA. So we really want to get them in. They may have taken it last week, but remember, we had a timing code error, so we're allowing them another opportunity to take the test under the correct time. Please check your mailboxes. If you have seniors in your first period this morning, please send them down. We do understand that some passes have come back already because they have not been seen since the school year began. So please, if you do happen to see these students around campus this morning, please remind them to come down for testing. And we want to wish Ms. Simmons, our guidance secretary, a happy birthday. Woo!
another day here at Georgia Smith High School, land of the Mighty Tigers. Happy Monday. This is your principal, Mr. Body, filling in this week for the Tiger TV Network. Today is Tuesday, October 20th. It's a Maroon Day, which means we begin the day in first period. A reminder, as Mrs. Rome just so eloquently said, a reminder that the retake of the ACT school day is this morning. Seniors who have not passed the FSA must report to the gym. Teachers, passes for these students were placed in your mailbox. So if you've not checked your mailbox, please do so. And have those students report to the gym immediately. Also, next Thursday, October 29th, is the PSAT for our ninth graders. Students, please prepare yourselves by studying your student guide, which was distributed a couple of weeks ago. Faculty and staff, I'd like to thank you for participating in our first ever Tiger Time, our after-hours event. We hope you enjoyed those few moments to unwind with your coworkers. As the rain fell, the wind blew, the sound of jazz was played. It's our goal to do this once a quarter. But please remember, in the interim, you are and will always be appreciated. Also, if you've not picked up your new Middleton polo shirt, please see Mrs. Warren in the front office. In other announcements, today is day 2 of our homecoming festivities. It's Back to the Future Tuesday. And for your planning purposes, tomorrow is Minions Wednesday, followed by a Scream Thursday and Tiger Pride Friday. By the way, we take on Spoto for our homecoming football matchup Friday night here at home. Don't wait, buy your tickets now.
not listening. Good morning, children. Good morning to all. I'm going to take attendance very quickly, and we're going to get this show on the road. And in fact, let me give you guys back your tests. That way you can have them. Well, I mean, I already went over it, so I already went over them in class, and let's see. Yeah, two tests. Gabriel and so there's notes on it. I'm sure you've heard. All right. So everybody has their test copy back now. We let Sophia in, and I want to make some observation or tell you about some observations that I made, whether you submitted your work online or whether you submitted it in person, if you were here. Let me go over the agenda real quick, and then we'll talk about that. So today we're going to review product and quotient rules, go over any questions you have, and then we're going to focus on the chain rule because this is one of the, well, it is the most important derivative rule, because most functions that you're going to be dealing with are not very simple functions. They're going to be composite functions.
Oh, yeah, I had a question on the homework you gave us.
Okay, so give me a minute. So we're going to focus on that, and then we'll move on if everybody feels comfortable enough to do that. So let me unshare this screen, and let's talk about the observations I made, because many of you, I would say about 65% of the AP Calculus AB class, at this point here, would not pass the AP exam. And it's not because you don't know the material to this point yet, necessarily. It's because you don't want to write. And in higher math, it's mostly writing. It's not so much, oh, I got to plug this into my calculator and get an answer, all right? So it's serious business, because as I told somebody this morning, you guys are in competition with each other the day you take that test, okay? If, you get 2 perfect scores in the nation, they set the standard for the rest of your scores, okay? The rest of the scores follow through. So you really, really, really want to make sure that you're very precise, because again, the graders don't know you from a hole in the wall. They don't really care whether you pass or not. They're just there to do a job of grade the paper, all right? And that's all they care about. And they're either going to see what they want to see or not see it. So what I saw was things like, first of all, number 1, you need to write down the original problem. You must do that. You have to do it, all right? So if you have something like f of x equals, I don't know, what did I give you? Like 3 to the 2x or something like, or no, I wouldn't give you that. 3 to the x, let's say. All right. And so what I saw on the paper was over here, I saw 3 and x and maybe something like this. And over here, I saw, ln 3. And then down here somewhere, I saw ln x times 3. So all this weird stuff, nothing was concise. Everything was like all over the place on the paper. They're not going to put up with that. I'm going to tell you right now, if they have difficulty reading your work, or if they have difficulty finding your work, they're not going to hunt it down. If it's not right there in front of them in a nice, logical, concise manner, then you're not going to get credit for it. Even if they find it later on and say, oh, here's number 1. It doesn't work like that in AP, okay? I'm not kidding. And in fact, they're very, very strict about it. They're like, you're in a college level class. So with the COVID last year, I'll just tell you a little true story. We had to do these live webinars with these people from AP because, they still tested the kids, even though it doesn't count, blah, blah, blah. And so they said that they had put these very, very sophisticated testing, protocols in, so that way, what they actually, the one guy, he actually sat there and he goes, I hope they cheat. He goes, because I want to nail them. they are not, they are not in your best interest. They're there to grade the test and see if you can pass it, and that's it. All right. When I heard that guy say that, because he was like happy about it. He's like, let them. He goes, let them try and cheat. He goes, because we're going to come after them and we're going to put the double F on their college transcript. And by the way, if you get that, you never ever get into a university anywhere in the world. Double F means you plagiarized or you cheated, and no university wants a kid with a double F. So anyway, they were like in their glory about it. They're like, let them. The guy was salivating. I'm not kidding. And so I thought, oh my God, if any kid tries to like click on something or whatever, they're going to get nailed. So just remember, that was my big realization, that maybe they're not necessarily evil people, but they certainly don't care about you or whether you pass the test. They're in it to make money. That's their end game. I hate to say it, but they're in there to make money. And you guys are in it for your future. All right. So what I force you to do is for a reason. Okay. And because I want you to do good. So I'm not yelling at you. I'm telling you, you guys need to improve on this. Otherwise, you're going to have a big problem come the day of the AP exam, because they don't put up with anything. And if they don't see the work there, you're not going to get credit for it. So, you have something like this, and then I'd see something like this. Okay. You need to say f prime of x equals. You need to denote your functions properly. All right. If they give you f of x, you find f prime of x. If they give you y, you give them y prime. You must follow the same thing that they started you with. You must use the proper notation. And for something like, I don't think you had, you didn't have product rule on your test, but in homework, what I noticed with the product rule, you would do, this, okay? There's no y prime or f prime or anything there. There's no rule painted out for the grader. So if they tell you to solve something using the product rule, you need to say, grader, this is the product rule. It's x e to the x prime plus e to the x times x prime, okay? You're telling them, I'm going to take the derivative of those particular factors, and then right underneath, you need to say, well, that's x e to the x plus e to the x, and then, continue on. Any questions on that? So most good calculus teachers, because I've worked with some of the best in IB, I'm sorry, I got to keep letting kids in, do the same thing I do. We work the same way. And these are teachers who have stellar pass rates as I do. Remember, I've had 100% pass rate since like 2012, 2011, something like that, both in AB and BC. Last year was the exception. So we know what we're doing and we're trying to help you. And so it would be appreciated if you would kind of like meet us halfway. And even at the halfway mark, that's not enough. You need to push yourselves to be legible, to be neat, to be organized, and to write everything down. And by the way, answers only, you get 0 credit here, and you're going to get 0 credit on the AP exam. So how I treat you is like an AP grader. So it's a harsh reality to have to like deal with, but I do it for a reason. I'm not going to say, oh, my poor baby, I'm going to give you +6 points because I feel bad for you. I know you tried. You don't get credit for trying. You get credit for what's right, and you don't get credit for what's wrong. So I have to be that way. You guys understand that? You see where I'm going with this? So please start to show your work better. And some of you, by the way, do a beautiful job. There were many kids who, man, they wrote out every little thing. It was beautiful. I even wrote beautiful on their papers. It was exquisite work. And so, look for those people. If those of you want to brag about who got the beautiful and the nice work and all that, seek those kids out, because that's what AP is expecting. Okay. So there were questions on the 4.3 homework or the chain rule. Which one was it again?
Okay, well,
Chain rule. Okay, so questions on the chain rule homework. Which one?
number 9 and 21.
9 and 21. Anybody else have any questions on chain rule homework? Online?
I do, but
Yeah.
can I?
Which one?
Okay. 1D and 5.
5? Okay. So I'm going to go in order. So we'll look at 1D. In 1D, we have h of x. So this is 1D. And let me make that a little darker. So h of x is equal to root x plus 1 quantity squared, right? And they want you to find the derivative in two ways. One by using the chain rule, and then by multiplying out and differentiating. So I'm going to use the chain rule first, all right? So using the chain rule, we need to identify an outer and an inner function. So what was your outer function? The person who wanted to see 1D, what was your outer function? Or did you not know?
I wasn't. Is it x squared?
Good, it's x squared, all right? So I'm going to call that outer function f, and we're going to say it's x squared, right? So what's the inner function then, which I'm going to call g?
Square root x and then plus 1.
Right, so the stuff inside, thus inner function, inside the parentheses, the radicals, the exponents, whatever, right? So remember that the chain rule says that if you have a composite function and you want the derivative of that, then you have to take the derivative of the outer function first, recompose it with the stuff that was originally inside, and then multiply that result by the derivative of the stuff inside, okay, or the function that's inside. So if I take the derivative of the outer function, it's 2x. Do you agree?
Yes.
Okay, now I want to recompose this derivative of, so I took the derivative of the outer function, I want to recompose it with the stuff inside, and all that means is that wherever there's an x in my derivative, I'm going to replace it with the stuff inside. You with me on that?
Yes.
I'm going to replace it with g. Now I need to find the derivative of g, and I'm going to rewrite this as x to the 1/2 plus 1 to make it ready for a derivative. So the derivative of g is 1/2 x to the negative 1/2, or 1/2 root x. Is that okay?
Yes.
All right, so chain rule says we're going to take the derivative of the outer function, recompose it with the inner. We did that. And then we have to multiply that result by the derivative of the inner. So all I'm going to do is multiply that by the result of the inner function. And these twos will cancel. So how it might be written in the answer key would be something like root x plus 1 over root x. Was that the answer he had? Anybody know?
Oh, sorry. So I checked the answer key and it said 1 plus 1 over x. X, the root of x. Sorry.
Well, I'm going to look it up right now, so hang on. This was 4, 1. Oh, 1 plus 1 over root x. Okay. So, yeah, because they did this. So, in the denominator here, you have a monomial, right? One term, which means that we could split up the terms in the numerator as root x over root x plus 1 over root x. And root x over root x is 1 plus 1 over root x. So, just a little bit of algebra. Make sense?
Yes, thank you.
Is that what threw you off was the answer?
Yeah, because I was getting something else and I was like, what are they doing? How are they getting this answer? But like I kind of got to it, but I wasn't sure how I did it.
So yeah, you probably did it a lot harder than it was, but because kids have
Like I had a bunch of stuff on my paper and I just kept erasing and I was just like, what's going on?
yeah, it was just a simple, splitting up the terms in the numerator over the common denominator. That's all. Tricky.
Thank you.
Mm-hmm.
Miss Wilson.
That was 1D. Did somebody call me?
Yeah. Scotty is in the waiting room. Can you please let him in?
I did.
Oh, okay. Sorry about that. He just told me again.
He did? Well, I'm thinking maybe he got bumped out or something, but I let him
I'm in
in.
now, yeah, sorry.
Oh, okay, that's all right. Okay, so then number 5. Number 5, we have h of x is equal to the square root of 2. Oh, and by the way, I almost forgot. If I do this by, so they wanted you to do it 2 ways. They wanted you to use the chain rule, and then they wanted you to multiply. If we multiply that, root x times root x is x, right? Plus 1 root x plus 1 root x is 2 root x, and 1 times 1 is 1. So if we take if we call this h of x, after we expand it out, we take the derivative of that, well, it's going to be 1. Actually, let me rewrite this as x plus 2 times x to the 1/2 plus 1. So we're going to have 1 plus x to the negative 1/2, and then the derivative of 1 is 0, which is 1 plus 1 over root x. So see, you get the same exact answer for number 1D. In number 5, we have h of x is root 2x, and we're going to take derivatives, right? So I'm going to rewrite this as 2x to the 1/2, and this is definitely chain rule, right? Because, you know, my outer function f is x to the 1/2, and my inner function is the stuff inside parentheses, radicals, exponents, or trig functions. So if I take the derivative of the outer function, I get 1/2 x to the negative 1/2, which is 1 over 2 root x. And if I compose that derivative with the stuff that was inside, that's going to give me 1 over 2 root 2x. Are you okay with that? Who asked me that question, number 5?
That was me.
So is this okay what I'm doing here?
Yeah.
And so
But
times,
I got an answer.
yeah, go ahead.
I got 1 over square root of 2x.
Right, because,
Oh, okay.
yeah, so see, g prime, which I didn't do yet, the derivative of the inner function is 2, so this is f prime g of x times g prime of x here, and these 2's will cancel. So you got it right, 1 over root 2x. Did he have something different in the back?
No, it was
Oh, okay.
the same one. I was just like, fractions just always confuse me when they're like put into this type of form.
We're gonna have a fraction class. Fractions, the children don't like their fractions. All right, number 9. Number 9 is a cute one. Who doesn't love E? So f of x
I think I got it right.
is e to the 2x. So your outer function is e to the x, and your inner function is 2x. So anything that's other than x in an exponent is a composite, okay, is your inner function. So the derivative of the outer function, of course, is e to the x. And if I recompose that with g of x, that gives me the same thing right back. So that's the nice thing about e. It's a property. Property, get it? Anyway, the derivative of the inner function is just 2. So if I do f prime g of x times g prime of x, that's going to give me e to the 2x times 2, and we would write that as 2e to the 2x. By the way, it should be known, if I gave you e to the 3x, anybody know real quick what the derivative would be? 3e to the 3x. How about e to the 7x? What would the derivative be? 7e to the 7x. How about e to the negative 4x? Negative 4e to the negative 4x. So if and only if you have, a constant multiple times a variable in your exponent, then what's going to happen when you're using the chain rule, but when you take the derivative of e to the x, it's itself, right? And then you plug in the stuff that was already in it. So that this is your f prime g of x. and then times the derivative of the stuff inside here, well, it's just times that constant multiple. So they always end up exactly as they were, except multiplied by the constant multiple that's in the exponent. Does that make sense? If you have pluses or minuses in there, like, you know, e to the 2x plus 1 or something, that's a whole different ballgame, okay? So just saying. That was number 9. And you can't multiply that. Oh, they didn't ask you to do that anyway, number 9. So that was 9. And then what was the other one? 21. So let's look at 21. So y is equal to x e to the 2x. So this is really, really important. When you look at this function, what thing comes to your mind the very first glance at this function? Anybody? Hello?
It's a product.
Good, it's a product. And that's really, really important because you have to use the product rule or the quotient rule if you see a quotient first. And then what's going to happen is within that rule, then you're going to have to apply chain. And most functions are like this. They're not all, you know, x squared plus 3, find the derivative, unfortunately. So what I have to do is I have to write out the product rule first. I'm going to say y prime is equal to x times e to the 2x prime plus e to the 2x times x prime. And what you see now is that, you know, when I'm going to take the derivative of this term, I say, oh, darn, I have to use the chain rule in this because this piece here is a composite. This one's easy. It's a 1. But this one, I have to use chain rule. So what's the derivative of that thing? Mentally. We just did this.
2e times, or 2e to the x.
I have to send you guys all the Starbucks. All right, and over here, the derivative is e to the 2x, is e to 2x times the derivative of x, which is 1, right? So what we end up with here is 2x e to the 2x plus e to the 2x, and you could factor out an e to the 2x and be left with 2x plus 1. And that is your derivative using chain rule. So if you see a product or a quotient, you have to apply the product or quotient rule first and then chain within it. Any questions on that? We didn't do the natural logs yet, did we? Did we do the natural log chain rules yet?
No, I don't think so.
What's
I
that?
don't think you did.
No? Okay, I didn't think so. So we're going to go there today. So let's just play around for a second. So what I want you to do real quick is I want you to take y equals, did we do this one yet? We may have done it, so you'll have to let me know. Have we done this problem yet? Root 2x sine 3x? Anybody? No.
I don't think so, no.
Okay, so what I want you to do is I want you to find y prime. I'll give you like 2 to 3 minutes to try and get it done. So my goal by Friday is to make you a chain rule expert. I have to find an app here. Oh, I gotta plug in my iPad. My iPad is not charged up last night. Oh, that didn't work out so good. Hmm. Let me know if you get an answer. Let's see. Same as 80. Anybody get an answer yet? Anybody? Oh.
I have an answer, but it's probably wrong.
Well, you don't know. Maybe it's not. What'd you get?
I got 3 times root 2x times cosine of 3x minus the sine of 3x over x root 2x.
The whole thing over or just the sign?
Yeah, the whole thing over it. Oh, no, sorry, just a sign, just a sign.
Oh, okay. I know that's all sideways and everything. So let's try.
And then x before that root 2x too.
Here?
Yeah, thank you.
Oh, okay. So let's see. First and foremost, we have a product rule, right? So I'm going to write out the product rule. We have root 2x times the sine of 3x prime plus the sine of 3x times root 2x prime. Is everybody okay with that? Now, this was tough because here, no, you don't. No, you don't. It's not a composite within a composite. We need to talk about those. But anyway, this is going to be root 2x. Now, the outer function is the sine of x. So the derivative of that is going to be the cosine of x. But we're going to replace x with the stuff inside. And then we're going to multiply that result by the derivative of the stuff inside. Is everybody okay with what I just did? This is my sine of x. Here, sine of x is my outer function. So the derivative of that outer function is the cosine of x. But I have to replace the x with the original inner function. And then I have to multiply my f prime g of x, which is this right here, by the derivative of the stuff inside, which just happens to be 3. Is everybody cool with that? The lack of answers is astounding, people.
Yeah, I got that.
Okay, good. You got that part. Now look, I have to take the derivative of this square root of 2x. So, I want to think of it, or maybe write to the side somewhere that this is quantity 2x to the 1/2 power. So when I take the derivative, I know I'm using chain rule. My inner function is 2x. My outer function is x to the 1/2, so I can use the power rule for that. So the derivative of the outer function is 1/2 x to the negative 1/2 times the derivative of the inner function. And I'm going to replace this here with the stuff inside. Is everybody okay with that? If you're not, please don't be embarrassed to ask or whatever. This is super. I cannot stress the importance of this rule.
Why is it times 2?
Because, all right, so if this is my function that I'm taking the derivative of, I have an outer function, which is, it's chain rule. Anytime you see parentheses with stuff inside to a power, you see a radical with some terms inside, you see e with some stuff inside, or you see a trig function with anything other than x inside, that's a chain rule problem. And 99.9% of your functions are going to be chain rule problems. So that's why I'm saying I can't stress enough how important it is to get this right and to learn it. You can't bomb these questions on a test and move on. You will always use the chain rule. You will always use any of the derivative rules. They're not going to ever go away. So even when you go backwards, they're not going to go away. So it's really, really important. So the 2 comes from the derivative of the inner function. Inner function is 2x, so the derivative is 2. And what I notice is that these 2's right here and right here cancel. So let's try and put this together. What we're going to have over here is 3 times root 2x times cos 3x. And on this side, or this term, we're going to have, looks like sine 3x over, now I'm going to rewrite this piece right here as the square root of 2x. Now, I don't know where the other x came from in here, but you were so close, yet so far. Because in AP Calculus, even though all of your work is beautiful and, it's all nice and legible and all those things, the derivative is unique to every function has a unique derivative. So if this is what you wrote down as your answer, they would go like this. It's wrong. It's not the derivative. The derivative is this. So you were very close. So I don't know where your other x came from. I'm not quite sure. But it shouldn't be there. But you did a good job. Just got to be a little more careful, that's all. Because it's true, it's a lot of work. So think of it this way. Imagine your neighbor said, hey, will you come rake my leaves? That's a lot of work to rake leaves. I mean, a lot of leaves, like billions of tons of leaves. I have this little rake. I want you to come in my backyard and rake the leaves, and I'll pay you $100. And you're like, cool, right? You go over there and you do all that backbreaking work in the hot sun, the humidity, you're all sweaty, you're drenched in sweat, you're dirty, you're tired, you're in pain. And then they say, you know what, I don't think you did a good enough job, so you missed a leave over there, so you don't get your $100. You'd be pissed, right? You'd be mad. Well, the same's going to happen in AP. You're either going to get it right or you're going to get it wrong. And I want you to get it right. Okay, so this is more along the lines of the types of functions you're going to be dealing with. And some of them are far worse than this. But we have to master chain rules. So I just went online while you were working on this, and I found a chain rule worksheet. And I'm going to have you do that for extra practice. But let's talk about the natural logarithms for a minute. What I want you to know is that the derivative of ln x is equal to 1 over x. Okay? The derivative of the natural log of x is 1 over x. That's a derivative rule.
And that's no matter what.
No matter, well, it'll always just be x.
So what if it's ln2?
That's different. That's a chain rule.
It's chain rule, but you still have to do.
Well, if it were the natural log of 2x, the outer function is ln x, and the inner function is 2x. So the derivative of the outer would be 1 over x, recomposed with the stuff inside, times the derivative of the inner function. So that's a cute little problem because it turns out to be 1 over x anyway. All right, so look.
Oh yeah, then it would be 2 over 2x.
Right. Yes, So the derivative of ln x is 1 over x. In calculus, we don't use the log log because we like working with base e, because base e is the natural log, and we use e in a lot of our applications. So we don't use baby logarithms, we use the real deal. They're both the real deal, but anyway, they're nicer to write too. This is a pain to write constantly. So anyway, we're going to use the natural log, and the derivative of the natural log is 1 over x. Now, the natural log is often in chain rule problems. Here's an example. Y is equal to the natural log of 2x plus 3 over x squared plus 4. Whew. I see a quotient in there, I see a natural log, where do I begin? This is a chain rule on top of it, yada, yada, yada. First thing, let me remind you of a few rules of logarithms. The product, or the sum rather, of two logarithms can be written as one logarithm of the product. Okay, remember that from algebra? And the difference of two logs can be written as one logarithm of the quotient. And finally, if you have a constant multiple being multiplied to any logarithm, you can write that, it's called the exponent rule. You can write that as 1 log of x to the m. Remember those rules? They're still going to come in handy in calculus. So if you've forgotten them, you might want to jot those down. You can expand the product. So if you're given a product of, you're given the product of a logarithm, you can expand it out as the sum. If you're given a quotient, you can expand it out as the difference. If you're given, you know, ln x to the some number or whatever, you can take this exponent and bring it down in the front like you see here, expand it out and then work with it that way. Or you can go the other way. You can start from here and rewrite it like so. So it depends on what you need. What I have here is I have a logarithm, all right, with a quotient inside. And I'm thinking as a kid, oh my God, this is going to be so hard. It's really not bad. Again, identify your outer function, which is ln x, and you know that the derivative of that is 1 over x. It's easy peasy, right? And then identify your inner function. Well, that's not so simple. That's a quotient. So the derivative of that inner function, you have to use the quotient rule, right? And by the way, some of you did use the quotient rule on this test. I was actually impressed that most of you used it correctly. Some of you did not. The quotient rule is very, very, very specific rule. It says that if you have a quotient, you must take the derivative of what's in the numerator first, multiply it to the denominator, and then subtract from that the stuff in the numerator times derivative of denominator over denominator squared. Some of you were taking the derivative of the numerator first, which, you know, if it was a constant, it was 0. But when you multiply 0 times the stuff downstairs, you were still coming out with the stuff downstairs. So you weren't putting a 0 in its place. So anyway, you got to be really, really careful with that. And some of you took the derivative of the bottom first. But you didn't have to use quotient rule on any of them. So anyway, the quotient rule says we take the derivative of the top, multiply that by the bottom, subtract from that the stuff on the top, times derivative of the stuff on the bottom, over the bottom squared. Right? And I'm going to clean that up. So that's going to be 2x squared plus 8 minus 4x squared minus 6x over denominator squared. And combining that, or simplifying that a little bit further, looks like we're going to have negative 2x squared minus 6x plus 8 over denominator squared. And I'm thinking I might be able to factor out a negative 2 on top. And that'll leave me with x squared plus 3x minus 4 over x squared plus 4 quantity squared. And what are we going to go? X plus 4. Yeah, okay. So that's going to give us negative 2 times x plus 4 times x minus 1. No. So what I was trying to do here, so I'm going to skip this mess. What I was trying to do is cancel with a factor downstairs, but it's not going to happen. So good. So I've simplified the numerator as much as I could. You could factor out a negative 2. You could factor out just a negative, whatever you want to do, but I'm going to leave it. So now we have to put this together based on the chain rule, right? The chain rule says we take the derivative of the outer, recompose it with the stuff inside the inner, and then multiply that result by the derivative of the inner function. So we've got our f prime. So we're going to have f prime, but instead of x, what do I need to put in there? Anybody? Yeah, g of x, which is this thing right here, right? So I need to substitute this in. So right here, this term here is my f prime g of x times g prime of x, which is over here. Is everybody okay with what I just did?
Yes.
Yeah.
Okay. Sort of. We're going to do more, don't worry. Now, you can't leave it like that. You have to simplify it. So we're going to simplify it. The first term, or the first factor, since it's a product, can be rewritten as x squared plus 4 over 2x plus 3, right? We just flip this thing. This is a little complex fraction here. And if we flip it, this is what we get. Times, we've got negative 2x squared minus 6x plus 8 on top. And of course, we've got x squared plus 4 quantity squared on the bottom. And what we see is that we can cancel this factor with one of those. And so that's going to reduce to negative 2x squared minus 6x plus 8 all over the quantity 2x plus 3 times x squared plus 4. Generally, we'd leave it like that. I might go further. I don't recall. I remember x plus 4, x minus 1, so I don't recall anything from factoring the numerator that will cancel out with the denominator. If there is, though, you need to, do that. But anyway, there's the answer. So it's some work, right? It's some work. I'll let you catch your breath for a second.
You don't exactly have to, right? Because you still.
Well, to simplify, you need to flip them. Because you have to write your final answer like this. And if you don't flip it, you might have a problem. So what I think you're saying is, and I can see it, of course, but I can see that in this form right here, that this factor is going to cancel with one of those. So I'm still left with 1 over 2x plus 3, which is what we get right here. Is that what you're saying? Yeah, so you could do that, but just be careful with it. All right, let's look at something simpler than the one I gave you. Y is equal to ln of 3x. Whew, much nicer, right? My outer function is ln x. My inner function is 3x. So I know that the derivative of my outer function is 1 over x, and the derivative of my inner function is 3. And so if I want to do my f prime g of x times g prime of x, which equals the derivative, then I've got 1 over 3x times 3, which is 3 over 3x, or 1 over x. Is everybody okay with that?
Yeah.
Good. What if you had, yeah,
Are all of them?
what do you mean, all natural logs of,
So if you do natural log of any coefficient at x, you're always
yeah,
going to get
yeah,
1 over x.
yeah.
You can do ln 1,500,000 x, and it would still be 1 over x.
Right. Because,
Weird.
no. So think about it. You're recomposing this bottom with the stuff inside, and the derivative of the stuff inside is always going to be a constant. So they're going to cancel regardless of what the number is. So yeah, it'll always be 1 over x. Here's another one. F of x equals ln root x. What would we do with that? Why is this delaying? This is delaying coming through the Zoom today. There's a chat message. Oh, by the way, I almost forgot to tell you because I think you were muted when I said this to the 2 kids in class. I posted an announcement this morning. I set up a remind.com account for AP Calc AB, only for the AB kids, and the passcode. And what I want you to do is I want you to sign up to that account. That way, if you have questions, concerns, you need an extra lesson, you need blah, 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 once I'm gone, then you can use that to communicate with me. All right, so make sure you go to remind.com and set up that account. That way we can keep in touch and I can work with you guys. And I can also send a mass message, hey, I'm going to hold a live review on, YouTube or whatever. And those of you who want to join can. So you'll get the message. All right. All right, so what about the natural log of x? What is that? Is that a product? What is it? Is it a chain? Is it a quotient? What's the natural log of x? Anybody? Is that the natural log times root x? No, it's a composite function, right? So remember rules of logarithms. I could write this as ln x to the 1/2, couldn't I? And the exponent rule of logarithm says I can bring that exponent down front and write it like this. Yes? Well, guess what? I don't even have to use chain rule anymore, do I? I could, and if I do, my derivative would be 1 over root x times the derivative. So, right, it's 1 over x. I'm going to recompose it with the stuff inside times the derivative of the stuff inside, which is 1 over 2 root x quantity squared, which is 1 over 2x, because that would get rid of the radical. But guess what? I can rewrite it in a simpler form and say, hey, that's just 1/2 times 1 over x, which is 1 over 2x. You see why knowing the rules of logarithms is nice? Because it can save you a ton of work. Here's another one. F of x is equal to the natural log of x squared plus 1. Now there's the, I don't know what they call it, the sum to product rule or something like that for logs. Remember, if I have a sum, I can write this out in expanded form. I could actually write this as ln x squared plus ln 1. And by the way, what is the natural log of 1, please? Yeah, all right, so hang on, I'm sorry, I'm reading the chat and somebody's asking, is there going to be a submission for 4.4 homework? Yes, there is going to be a submission. I forgot to include it last time because it's just been chaotic. Or I think I forgot to include it. I don't know, I have to go look. But anyway, I'll open it up and you can, if you submit it via email because the button wasn't there, because some of you do that, then I'm going to ask that you resubmit it through the thing. I just forgot to do it. So I'll do it in a minute and I'll open it up till like 5 o'clock today or something. So what's the natural log of 1 again?
0.
Yeah, it's 0. Don't forget that ln e equals 1 and ln 1 equals 0. So some other little properties of the natural log. So that thing's gone, right? And I could use exponent rule here. Again, you see how beautiful this is? So the derivative would be 2 over x. Done. Or I could chain it. If I choose to chain this, then I would say, well, you know, the derivative of the outer function is 1 over x, but I have to recompose it with the stuff inside. And now I have to take the derivative of the stuff inside. That doesn't seem right. How could this be? Hang on. So this is 2x over x squared plus 1. That's not factorable.
That's what I got as the final answer.
Yeah, through chain. Well, no, it's just bizarre because what I say is true. This is ln x squared plus ln 1, which is 2 ln x plus 0, which would be 2 over x. I'm trying to reduce this in my head, this one, to 2 over x, and that's impossible. Unless I conjugated it, maybe. Maybe if I conjugate it, but that would be ridiculous. Still, I get 2x cubed minus 2x over x to the 4th minus, no, it's just, so anyway, it's a weird thing. Well, we have another quiz this week. So yeah, so what I want to do on Thursday, thanks for reminding me, on Thursday, when you come to class, whether it be online or in person, so if you're coming in person, make sure you bring your computer. You're going to open up WebAssign. Remember that I'm going to have the lockdown browser. It's all, you don't have to download anything. All right. WebAssign takes care. It's like AP, although you guys didn't take the AP exam last year, but AP kids last year had to take online, and while WebAssign is not as sophisticated as AP, it records every click you make. So you're going to turn on your camera so I can watch you. And what you're going to do is you're going to answer a few derivative problems. You're going to find the derivative and you're going to click on the correct answer. I'll make it multiple choice. And it's going to be sections 4.1 through 4.3. So that's basic derivative rules, derivatives of the trig functions, derivatives of exponential functions, so e to the x, b to the x, and product and quotient rule. And a bonus will be chain rule.
I have a feeling I'll do better on the bonus than the actual quiz.
You better do better on the actual quiz because the bonus question is not worth as many points.
True.
All right, so on Thursday, I think you guys are good enough that you can do the basic derivative rules without any problems. The exponential functions, the sine, the cosine, the tangent, the trig rules, and the product and quotient rule. So the other thing you're going to do, because, you know, if you're on WebAssign and you're taking a quiz, if you've got a product or a quotient rule, so like, you know, power rule, you could pretty much do that in your head. But product rule or quotient rule, you need to do work to get to the answer. There's no way you don't do work and get to the answer at this stage in the game. So what you're going to do is, if you're at home online, you're going to upload your Scratch work to me, because that work must warrant the answer that you give me. Because if it doesn't, then I'm going to deduct some points. So in other words, if you've got the right answer from some miracle, yet the work on your Scratch paper doesn't warrant that work, or it doesn't come close to that work, then I'm not going to award you credit. Okay? Because I know some things that are going on, and we're trying to take care of that. So you're just going to upload your Scratch paper when you're done. That's all. It's going to be an easy quiz. It'll help add to boost your grades, for which I was very lenient about, by the way. The grades would have been much worse if I would have graded you as I should have, as if I would have been as harsh as I should have. But I figured I'd be nice on my last week here. So trust me when I say. And even one student said in class, he's like, wow, I thought my grade was going to be a lot worse. And I said, that's because I was very nice about it. I didn't take off as many points as I should have.
Thank you.
You're welcome. But the next quiz, ooh, the pen will turn evil red, and I'll be going like this. Right, and I'll still mark them wrong. Okay, so anyway, I'm kidding. So the 4.1 quiz, what's in here? If I missed a quiz on Friday, oh yeah, okay. So there's a couple of you that it's actually a 4.1, 4.2-ish quiz, mostly 4.1. What we got to do is we've got to get together. So I gave the kids 30 minutes to complete 6 problems. Did I gave you an extra credit too, right? On that quiz? Yeah. Plus an extra credit. So I need you, when do you have 30 minutes free? Do you have like a research class or something during some block, or? Well, let me know when you have 30 minutes free. It needs to be by Thursday though, because on Friday, tomorrow morning, what time? I need specifics. Tomorrow morning at 8:30 to 10. Yeah, so, okay, so I have block 5 tomorrow morning. So just join in my Zoom, and I'll pin you so I can watch you, and I'll post the questions for you, and you can take it then, okay? So I'm just making a note so I don't forget. Tomorrow morning, the 21st, we'll hit. All right, great. If anybody else missed it, you need to let me know, because everything needs to be completed by Thursday, because after Thursday, there will be no new grades, because I have to close my grades out on Friday. So technically speaking, you know, I could give you a quiz next week or something if I wanted to, because you know how grades take a week. We have a week to get them done, but I'm leaving Friday, so I don't want to leave any unfinished business. And say, the heck with the kids' grades. I'm done with this place. I'm out of here. No, I wouldn't do that. Okay, so anyway, we have to make sure that everything's done by Thursday. All right, so here's one for you. I want you to try this one by yourselves and tell me what the answer is when you're done. I want you to find f prime of x. I'm still gonna figure out this one because there's something not right with that problem. I think it's just a not right. They just want you to just chain anyway, so they probably made it up like I do.
Everybody got it?
Yeah.
Is it, I think it's 1 over S ln x.
Anybody else get an answer yet?
I got the same thing.
The same thing?
Same here.
Ooh, 3 people. So let's see. The derivative of the outer is 1 over x, but I'm going to recompose it with the stuff inside, right? Times the derivative of the inside. Yay! Very good. Any questions on that? Here's another one. And then I'm going to give you a doozy, but it's not going to include a natural log, but I need to show it to you. So can you find the derivative of ln e to the ln x? I know this derivative by heart. James, are you finding the derivative? Focus, focus. And talk to your girlfriend after you're done with your mathematics.
Haha, you're funny.
Anybody done yet?
I got 1 over x.
I can't hear you. You're coming in really spotty. Let's see, I've got a message. One over x. X, okay, so I've got 2 answers. I've got 1 over x. I've got x over e ln x. So the 2 answers I got were 1 over x. I got e over, make sure I write that right, e ln x. I got another 1 over x. And the answer is 1 over x.
Yeah.
And the reason is so is because what is e to the ln x? Well, ln e is 1, right? So e to the ln x is x. So you think of these 2 as canceling. Okay?
Yeah.
Remember that? So you could really write just, you could simplify this to this. And so the that's not the derivative. The derivative is 1 over x because this simplifies to ln x. Questions? Okay, here's one for you. I want you to find the derivative. No natural log, just an innocent little function. Find the derivative. Good, good, Sophia. Are you guys that got 1 over x? Excellent. Oh, Shashank joined Remind.
I got it.
Okay.
I'm not sure how to do it.
I think it's 0.
Could be terribly wrong.
I think you are, but maybe you're not. Anybody else have an answer?
That's not zero.
Okay, we take this back then.
Zero is no mistake now.
I got 2x minus 2 over x cubed. No, so the 2x is by itself, and then minus 2 over x cubed is,
Like this?
Yeah.
Okay. That's a minus there. So you could expand this out if you wanted to. Let me get rid of this y prime. If you wanted to, you could FOIL this out. Because, you know, when you're told to find the derivative, you can use any method that you feel will work best. Sometimes we choose a particular method and it turns out to be a nightmare. And we find that out very, very quickly. But most of the time, we're going to choose the right method by inspection. And, you know, if you wanted to expand this out and FOIL it, you could do that. If you expand this out, you're going to have x squared. Now, look, when you have x times 1 over x, that's 1, right? And 1 plus 1 is 2. And then 1 over x times 1 over x is 1 over x squared, right? So you could do that and take the derivative. So you had 2x. If you wanted to, actually, you could write this as, you know, x squared plus 2 plus x to the minus 2, and then take the derivative and get 2x minus 2x to the minus 3, or 2x minus 2 over x cubed. So good job. You could do that, or you could use the chain rule. Let's use the chain rule. What's the outer function, somebody?
Squared.
X squared. Yeah, good. And the inner function, of course, is all that mess inside, right? And in fact, I'm going to write g as x plus x to the minus 1, right? Because I know I'm going to have to take a derivative. So again, I'm going to take the derivative of the outer function, recompose it with the inner. So the derivative of the outer is 2x, but I'm going to replace that x with the mess inside, right? Times, now I got to put the derivative of the, well, I'm going to use parentheses. Derivative of the inner function is 1 minus x to the minus 2. So what I have here is this thing. And I have to clean it up. I have to try and get it to look like 2x minus 2 over x cubed, because that's the answer.
Pull an x out of the first parenthesis.
Here?
Yeah. Divide that by x and put it into the 2 area. So it's 2x times 1 plus 1 over x squared. So you can do differences.
Yeah, you can do it that way. There's many ways you can approach it. So you could factor out the x there. We factor out an x, we are left with this, right? If we factor it out of this term, but this is a product, so we also need to factor it out of here, right? Is everybody with me on that? And there's no 2 here. So we need to be very, very careful. So I'm going to do it a different way. First, I'm going to distribute. Oops. And now I'm going to FOIL. Did I do that right? 2x minus 2x over x squared plus 2 over x minus 2 over x cubed. And of course, an x here is going to cancel with an x here. So I've got 2x minus 2 over x plus 2 over x. Those are going to cancel. Minus 2 over x cubed. And so we get the same answer. So the other thing, I don't know who was saying it, but if you wanted to factor out an x, you could definitely do that rather than foiling that. So you see, it's never the calculus that's going to get you. It's going to be the algebra. It always is. But if we pull out an x here, and that's why I challenge you to do it the hard way. Because what that does is it refines your algebra skills, and that's very, very necessary because algebra never goes away. So, if you did pull out the x, remember, factoring is like dividing every term by x. So what you're left with is 1 plus 1 over x squared times 1 over x minus 1 over x. Is that right? No. 1 over x squared, I think. So anyway, play around with these things. They're super important. And the reason why I kind of harped on these today, these natural logs and whatnot, is because that's what you're going to be dealing with very soon, all the time. All right, so what I'm going to have you do is the following. Your homework.
Study for the quiz.
You need to study for the quiz. There should be really no study at this point for sections 4.1, 4.2, and maybe 4.3 a little bit. You guys seemed really pretty well, you seemed actually, which surprised me, more well versed in the quotient rule than you did in the product rule. So find the rule for which you're weak at and focus on that only. If you know how to use the power rule, you don't need to study for it. If you know that the derivative of e to the x is e to the x, or b to the x is ln b times b to the x, no need to study for it. But if you struggled a little bit with the power or the product rule or the quotient rule, then focus on those. But I want to give you chain rule homework because, God, I wanted to get to related rates with you guys. And you know what? That's just not going to happen. The next derivative rule, well, the next thing to do is implicit differentiation. So Thursday after your quiz, you're going to learn, I'm going to teach you implicit differentiation because it's another extremely important, it's not a rule, it's for implicitly defined functions. And it's very, very important in order for you to be successful applying them in related rates problems. So we're not going to get to related rates, which is really sad. But yeah, I'm gonna throw something on here in besides the studying. I want you to do section 4.4 again, but just a few. I want you to do number 24. I want you to do 33. And I want you to do 32. So I did that backwards, but they're in different columns. I want you to do those 3. And the chain rule worksheet, which I'm about to post, after I post the 4.4 homework submission. So yeah, I'm laying it on you kind of thick today, and I apologize, but I don't know. Let's see, how many questions are on the worksheet?
2 questions. Each has
2 questions.
no, each has 26 parts.
Yeah, sounds like an AP exam. 3 questions with 26 parts. That's an AP exam. So,
Yeah, we got what the 85 was 2 questions, A through H.
but here's the deal with this chain rule worksheet. If, here we go, if it ever opens, there are 14 questions plus the answer key. And I think I'm not going to give you the answer key. It's not just an answer key, it's a total solution key. I'm going to force you to do it without the key, and then I'll post the key. So that's your homework. I'm done talking. You can start with those 3 problems from the book. I'm going to go into Canvas, and I'm going to put the assignment, the place for the 4.4 assignment, and anything else that I forgot to do the other day. If you have questions, let me know.
Miss Wilson,
Yeah.
the 4.4 homework submission separate from the section 4.4, what you just assigned us, right?
Right, so I gave you guys chain rule homework last time, right? And I forgot to put, according to what I'm being told, I gotta look right now. 4.3, yeah, there's no 4.4 submission for the last homework that was due. So under chapter 4 homework, I'm adding right now, section 4.4, the one that was due today. I'm going to call it chain rule part 1, is due today by 5 o'clock. So I'm going to put 5 p.m. tonight for 10 points. Save and publish. And I have to put a place for you to submit. So if you're done with it, as you should be, then I would expect your submission like in the next 15 minutes. If you're not done with it, it'll be blatantly obvious. So that was the one for, what was it, 3 through 19? Was that the numbers I gave you?
It was 1 through 19.
Sorry, 1 through 19. Odd.
You made the assignment, but there's no way to actually like submit.
Right, I'm putting it right this instant. So give me one.
Okay, sorry.
That's all right. All right, so it's there. And now I'm going to add another assignment, 4.4 part 2. And that's going to be due on Thursday. It's going to be 8:30 in the morning. I'm going to save and publish that. So it's going to be above, and I've got to edit it so I can allow a submission. And that's going to be for numbers, what did I say, 24, 32, and 33. So much to do in so little time. And all right, so save. So that's there. And I think that was all I had to do. Yes, 4.4. Oh, the other one I'm going to do is the chain rule worksheet. So I'm going to add chain rule worksheet. Now I'm going to give you longer on this one. You're going to still submit it by Thursday, but I'm going to give you till 5 o'clock to submit it because I'm kind of, you know, giving you a lot. Chain rule worksheet, edit, Online. No, online. So annoying. And yeah, till 5 o'clock on Thursday. And what I have to do is I have to attach the file, but I have to finagle it a little bit because I don't want to include the solutions because then why bother? Because I want you to try and get this for yourself. So I'm going to play around with that right now. If you have any questions about the 3 problems from the book, let me know. And let's see. Yeah, 14 problems. Perfect. Okay, so I'm going to upload the chain rule worksheet right now. And it's not that bad. Well, all right, maybe there's a couple that are a little bit tricky, but it's really not that bad. So I'm going to upload that right this instant. Document, upload. Chain rule worksheet, block 1. Submit. And length options. 1 and save. Beautiful. There it is. Mm-hmm. About the what?
Yeah, so I had my operation October 9th. So
Uh-huh.
And then there was the product rule. I wasn't there to learn it. I submitted it the next day.
Let me go into
But
this.
since it was like auto-graded and stuff like that.
All right, so let me see. Block 1. And grades. So
That was 4.3 product.
4.3.
Yes.
have two 4.3s in there.
The
Oh,
first
because-
one, October 13th.
Yeah, so what happens is,
You have an auto grading system.
right, so WebAssign, Canvas automatically assigns a 0 if the work is late. I can override it. So did you submit one for that? Because it doesn't show, I see one that you submitted, the second 4.3, which I guess was the quotient rule.
Yeah, I have image. Right.
No, but it has to be in here. That's what I don't understand. So,
It says resubmit,
oh, it does? Let me see, this was for 4.4, right? So let me look at this.
4.3 product.
Maybe I couldn't read it. So let's see, here it is. What the hell? Oh, not 2.8 there. That's bizarre. Let me go back. Let me go back. So maybe I pressed the wrong student by accident. So Gabriel. All right, so that's 2.8. 4.8.
2.5 and 2.8 also.
So 2.8 was back from September.
It's because I ended up submitting it later. The one for,
But when was your surgery again?
it was October 9th. The assignments that was due October 13th, I couldn't do because I didn't have the knowledge. Of the
That's
lack of-
fine. So just do them and submit them and I'll fix them.
I did. Submit it.
Nice music.
It says here I did submit.
For 2.8?
Yeah, I have.
Yeah, I have images here, but I don't have images for 4. Let me see. I don't seem to have an image. Or let me see what comes up. It takes a minute. It takes forever on this computer. It's like a nightmare of epic proportions to open a document on this computer. I can't deal. I cannot wait till I never have to use this computer again. If I could stay here with a good computer, I would stay. Well,
That's why I bring my laptop.
all right. So yeah, I have the document. The 2.8 document's there. It's there. There's 4 of them actually for that one. If I go back to the 4.3, that's the one I'm concerned about. I know that you were out with surgery, so that's an excused absence.
The others were actually with.
It doesn't show
And
them.
then I also have the image actually on me. I also have the notebook.
No, but it says 4.3. So the second 4.3, I don't know why that one's not showing up in the. Oh, I see, because it's the last 9 graded. Sorry, I'm in the wrong place. There's too many places in here. So 4.3. Bye. Okay.
Have a good day.
4.3. Bye, you guys. You're good. You can go. The image is here.
Okay.
It's here. I didn't see it because I was in the wrong space, but it's there. So, yeah, you're good.
All right, thank you.
Yep. Yeah, those of you online, have a fabulous rest of your day.
Have a great day.
And thank you. And we will see you on Thursday.